Let's go back to a concept we studied quite a while ago. Very straightforward one, the concept of speed, or velocity if you want to take out the vector part of it. We had said that speed was the distance covered divided by the amount of time that it took to cover that distance. Very common notion. We experience it every day when we're driving down roads. You're going a certain speed, you're going a certain number of miles per hour if you're in the US, and so on. If we replace the generic distance with the specific distance that a single wave travels in a certain amount of time, namely the wavelength, and then divide by the very specific time that it takes for that one wave to go by, we get this. We get the speed of a wave is equal to its wavelength divided by its period. We also know from a discussion on a previous page that the period and the frequency are inverses of each other, or the frequency is 1 over the period. So we can actually replace the period in that equation with the frequency and say V equals frequency times the wavelength lambda, which we'll do on the next page. So this is what we'll call the wave equation. Wave equation says that the wave speed is the product of the frequency of the wave and its wavelength. And it's nothing more than an extension of the previous discussion, the previous concept of speed, the distance traveled over time. Right now, we're going to just talk about situations where speed of a wave is the same in a medium regardless of how long the wave is or what its frequency is. So for example, when we talk specifically about sound, we'll say that all frequencies of sound travel at the same speed, which will make V a constant. Hopefully you can see that if we're going to consider this constant, if one of these variables goes up, the other one has to come down to make up for it and keep this constant. Likewise, if the frequency goes down, the wavelength has to go up. So let's finish with a couple examples. Remember that one of the things you can do to help yourself is to label things within a problem. So for example, how long is one wave? Well, we call that wavelength. If waves are moving at 10 meters per second, we know that's a velocity, and 2 waves go by every second. Now here you have to be careful. Are they giving you a frequency or are they giving you a period? It says that it's 2 waves per second. You have to understand that phrasing. Per second means that it's a frequency. Okay, so you're actually being given F there. So how long is one wave? Well, we know that V is the product of F and lambda. And if we're looking for lambda, then divide both sides by F, and you get V over F. So we'll divide the velocity of 10 meters per second by the frequency of 2 per second, and we get a wavelength of 5 meters. So here's a slightly trickier example. How fast is a wave moving? So again, we're looking for the speed or velocity. If it takes 2 seconds for it to go by, so a single wave, the time for that is called the period, t, and it has a wavelength of 18 meters. So our wave equation is actually in terms of frequency and wavelength. But we know that frequency and the period, which is actually what's given in the problem, are inverses of each other. So we can replace the F with 1 over t, and then multiply that by lambda. And this gives us 1 over 2 times 18 meters, or a speed of 9 meters per second.